Now we will discuss the view factor, also known as shape factor, also known as configuration factor, also known as angle factor. This is an important topic. Radiation heat transfer between any two surfaces depend on the orientation of the surfaces relative to each other as well as their radiation properties and temperature. What do I mean by saying that? Let us say we have a point source which emits point source of radiation. Let us say there are three surfaces in the surrounding of this point source. One is slightly tilted, one is perpendicular to the point source, and another one is slightly offset from vertical. If we see, this will point source will emit radiation and it will see more amount of surface area at this surface as compared to the other two surfaces. If we draw here, it will go like this, and at this surface area is like this. So if this is surface 1, this is surface 2, and this is surface 3. Surface 3 will see more radiation than surface 1, will see more radiation than surface 2. This proves that radiation heat transfer depends on the orientation of the surface relative to each other, as well as their radiation properties and temperatures. To account for the effect of orientation on radiation heat transfer between two surfaces, we define a new parameter called view factor. Accounts the effect of orientation on radiation heat transfer. View factor is purely a geometric quantity. Let us say this is a surface I and this is a surface J, then the view factor Fij is the fraction of energy, or radiation energy leaving surface I that strikes surface J directly. Surface I will emit radiation in all directions. Only some amount of it will be absorbed by surface J. So the fraction of energy leaving surface I that strikes the surface J directly is known as the view factor. So view factor is defined as Fij is integral over surface Aj over surface I cos theta I cos theta j upon pi r square dAi dAj, where theta I and theta r let us say this is a surface I, this is the surface J, its normal is this one, this surface is normal in this direction. Let us say this is Ni, this is Nj. And draw a line that connects the center of these two surfaces. And let us say surface J subtends a solid angle d omega by J on I. This is solid angle. Then the angle between normal and the line that connects the two surfaces is theta I and theta j. So theta I and theta j are angle between normals to the surfaces and the line that connects the two surfaces. The view factor Fji is 1 upon Aj Aj cos theta I cos theta j upon pi r square dAi dAj. As we can see, Fij is not equal to Fji. For a flat plate, view factor of flat plate which itself is equal to 0. If this is a flat plate and it emits energy in all the directions, this emitted energy can never be incident on the flat surface itself. So the view factor of a flat surface with itself is equal to 0. Similarly, for a convex surface, Fii is equal to 0. this kind of surfaces. Okay, this will radiate, this will radiate, this will radiate perpendicularly. Okay, this is but for a concave surface Fii is not equal to 0. Concave surface. Okay. If this is emitting, this can strike. So the V factor of concave surface with itself is not equal to 0. There are some rules of shape factor. Rules of view factor. First one is reciprocity rule. View factor Fij and Fji is related as Ai Fij is Aj Fji. Let us say we have two surfaces 1 and 2, and view factor of 1, 2 and view factor of 2 1 is F21 and its area is A1, its area is A2, then these two view factors are related as A2 F21. Second rule is summation rule. It states that the sum of view factors from surface I of an enclosure to all surfaces of the enclosure, including to itself, must equal to unity. This rule is nothing but the conservation of energy. Fij is equal to 1 when j is tending to 1 to n. So if we have an enclosure of n surfaces, then we will have an equations like F11, F12 to Fn. Similarly, it will go as F11, Fn2 to Fn is equal to 1. This is known as the summation rule. Third rule is the symmetry rule. Which states that if two or more surfaces that possess symmetry about the third surface will have identical view factors from that surfaces. Let us say we have a surface one and it contains side surfaces which are symmetrical. Let us say this is surface 2, this is surface 3. Surface 2 and 3 are symmetrical about surface 1. Then the view factor F12 will be equal to view factor 13. This is known as the symmetry rule. If two infinite parallel plates are kept at some distance to each other, then view factor of 1 to 2 is equal to view factor 2 to 1 is equal to 1, like this. Let us say this is one infinite plate and this is the second infinite plate, surface 1, this is surface 2. Then F12 is equal to F21 is equal to 1. Similarly, let us say a body is enclosed in another bigger body. Let us say this is a spherical cell, and a small body is kept inside. Let us say this surface is 1 and this surface is 2. Then view factor 1 to 2 is 1, but view factor 2 to 1 is not equal to 1. Similarly, for infinite concentric cylinders, F12 is equal to 1 is equal to F21. Let us say this is the inside surface and this is the outside surface of cylinder. This is denoted by 1, this is denoted by 2. Then the radiation emitted by 1 will be completely absorbed by surface 2. So F12 is equal to 1, but the radiation emitted by 2 is not only absorbed by 1 but by 2 itself. So F2 to 1 is not equal to 0 and also not equal to 1. We can derive this F12 A1 F12 is A2 F21. This implies F21 is A1 upon A2.